All right, can you hear me? Cool. Okay, yes, I think my talk title got lost in translation a little bit, but that's okay. Today I'm going to be talking about what's really just a cool trick that I found in the documentation for Matplotlib that lets us basically deconstruct a contour plot and represent it in such a way that makes it a lot more lightweight. And the reason that I'm doing this is that, well, the reason I chose this topic was that I thought it would be kind of broadly interesting to anyone who's using Python for data visualization, and it's not so domain specific. But the problem that I was encountering was that the types of data that I was working with that I wanted to represent as a contour plot that was interactive online were too big to basically fit into the browser. So if I tried to plot my data directly, I would crash my browser. So just as a bit of background, go to the next slide. There we go. So I work in the field of structural biology, and as a structural biologist, I'm really interested in the relationship between the three-dimensional structure of biomolecules like proteins and DNA and their function. So proteins are really just very big molecules made up of hundreds, well, usually thousands or tens of thousands of atoms. And by learning about the way that these atoms are oriented in space, we can usually make inferences about how proteins function. So there are three main methods that people use to do this. The old school way is X-ray crystallography, which is what like Rosalind Franklin used to learn about the structure of DNA. Probably the hottest technique now is called cryo-EM. It's basically taking electron micrographs of individual biomolecules. And there's a lot of really cool like image processing work that goes into analyzing these data, and lots of opportunities to use Python in that field as well. But the one that I'm going to be talking about is nuclear magnetic resonance. So the types of data that we're working with is basically radio signal that's emitted from proteins or other biomolecules that have been subjected to high magnetic fields and then perturbed with radio frequency energy. So what we can do is we can take a protein that we want to interrogate, to ask questions about its structure. We can put it into a high magnetic field, perturb it with RF pulses, and then the signal that it kicks off will kind of depend on the local chemical environment of the atoms in that protein, which we can then interpret to come up with like a structure or information about protein dynamics and things like that. So I was really having trouble with two-dimensional Fourier transform data. And the reason that I gave that whole spiel is that even though this is like a very specific type of data, I think making these plots will be valuable for lots of other fields as well. So this is a two-dimensional protein NMR spectrum, but similar types of plots might be seen if you're working with like geospatial data or any contour plot, right? So I want to jump into the code. Yeah, so this is mostly about data visualization. So I used a few different data visualization tools. The main one is Matplotlib, which is kind of the classic favorite, I think. And the thing that I mean, my big takeaway from Matplotlib is that it's very powerful, but also the syntax is kind of dense. So like it's not very fun to write code that ends up in Matplotlib plots. So the other library that I use is called HoloViews, which is a library that is sort of an API for Matplotlib, Bokeh, or Plotly, or a few of these other lower level Python data visualization libraries. So you can write code using HoloViews and then kind of just switch your backend and get a Matplotlib or a Bokeh plot. And this is really useful because we can use it to make Bokeh like interactive visualizations. And then I'm also going to be using a few like NMR specific libraries, either written by other people or written by me, and NumPy. So yeah, so this is what these 2D contour plot type data these 2D NMR spectra look like under the hood. So I'm importing the data with some other library that I've abstracted, so not super important. But at the end of the day, you just have a 2D NumPy array that has a shape that is represented on that 2D contour plot. So you have like an intensity value, a Z value, and then the location of that intensity value within the array kind of implies its location on our plot. And this is just like data taken straight from a spectrometer, and there are like 4 million points here, which I learned was more than Firefox or any other browser likes to work with. So you can kind of get a quick Matplotlib focused idea of what these data look like if you just naively plot that 2D array. And you can see that that's like pretty similar to what I showed a few slides ago. But if you then continue on and try to just shove that data directly into like some interactive data visualization library like Plotly that can do contour plots, if you run this code, you are going to crash your browser. So to get to the bottom of this problem, because I really wanted to plot these interactive 2D spectra, kind of went back and took a look at what was actually being plotted from my Matplotlib plot here. So if you kind of look at this, what you see is that Matplotlib is generating this quad contour set object. And digging through the docs for that, you can see that what Matplotlib does is when it reads in your 2D array, it converts the array to a series of coordinates for the contours, right, based on the contour levels that you ask it to give you. And then it saves those coordinates in one of these quad contour set objects. So I tried a bunch of different things before coming to this. Like I tried downsampling my data to like reduce the size. I tried like only like replotting small bits of big data where the contours were showing up, but none of these were really working for me. But this approach let me plot, instead of like my entire 2D array of like 4 million points, this approach lets me just plot like line plots based on these coordinates. So I thought this was a really cool trick. Yeah, so if you take a look at that all segs object that was in the documentation on the slide prior, if you look at some of these little smaller arrays that are stored in this all segs object, you find that they are like little contours. So I wrote a loop to just parse that and then put it into a format that works with bokeh or with hollow views. So all I'm doing is just looping through the list of arrays and pulling out the coordinates for each individual contour, and then putting them into a dictionary of lists that has like the XY coordinates for each contour. So since I said this is going in the browser, it's pointless to show it statically in a PowerPoint slide. So I have this Jupyter notebook here that has all the code that I just showed you. And if you feed the object that you generate from that list into hollow views, and then you set some options that make your data look just like an NMR spectrum with the right axes and things like that, what you end up with is a nice 2D plot that you can zoom in on and move around and play with as much as you like. So yeah, discovering this kind of enabled me to do a lot of really interesting analyses of these types of data as well that you can't do in some of the like pre-packaged libraries that ship with the spectrometers. So getting pulling out these contours from Matplotlib's, from under the hood of Matplotlib, I guess, to stick with my slide title, was super valuable and a really cool trick. So hopefully you guys can use it as well. That's it.
Nice.
Very nice. Does anybody have any questions?
So is that a 2D plot or is it a 3D that's rotatable?
So this is a 2D spectrum, yeah. But actually the only thing that's being plotted are the coordinates of contours. So yeah, if you plot the whole array, you end up with something that won't run in a browser. But yeah, I guess you're asking about the actual experiment. So you can do 3D experiments and get 3D data, but sadly, I haven't had the luxury of acquiring one of those yet for myself. But when I do, I'll give another talk for plotting 3D experiments in the browser.
How well does this work in the browser, this 2D plot? Is it take a few seconds to load or a few minutes to load?
No, it's more or less instant, because like Matplotlib is pretty fast, and it like separates the contour generation from the actual plotting. So like the big bottleneck is, I think, the browser trying to render all of this empty space, which is full of values that are below the minimum contour level and therefore not interesting. Yeah, so generating the contour, the quad contour set by Matplotlib is super fast, and then yeah, plotting this from here is like also super fast. Yeah, and so there's a big database called the BMRB, which stores a bunch of NMR data like this. I'm hoping that they will use some of this code so I can show you guys real production plots like this in the future.
So when you say in the browser, so you're, do you actually export it to HTML or SVG, or how, what creates these widgets that you're using on the right-hand side to zoom and pan and all that stuff?
Yeah, so this is like, so in the Jupyter Notebook book, I think Jupyter Notebook understands like these HoloViews objects. So all of the like actual rendering and stuff is done by HoloViews. So I didn't write, and nothing that I did has anything to do with like the actual functionality here.
Right. I'm just curious whether it's something that you could put in a generic web page, or do you need to use Jupyter Notebook?
No, it goes inside the general web pages. It's a bouquet is doing the rendering, and let's see, the stuff on the right side. It's completely interactive. It's all JavaScript.
Got it.
Bouquet is doing the let's see, the Python to JavaScript translation.
Nice.
Have you been able to share it with the company that makes the NMR machine or releases those the packages?
Yeah, well, so the database that people tend to send their NMR data to, like to put it into the public domain, they're interested in this. The people that maintain that are interested in this. The companies that actually make the software for the spectrometers are slowly coming around to modernizing their software, but it takes a while. Actually, the most recent version of the program that runs the spectrometer just offered the capability to like program it with Python 2.7.
Oh, wow.
Yeah.
Modernizing, huh?
Yeah,
It's probably more modern than what was there before.
that's true. Yeah. Yeah, the main like piece of software that people use to analyze these types of data, distinct from like acquiring them, you need to have the C shell. It runs in the C shell, and that's the first and last time I've ever had to use the C shell. It took me a while to get it to run using the Windows subsystem for Linux that I use here on this computer, and after a lot of troubleshooting, I realized that the path that I had, like as the default path in that program, was longer than the C shell would allow. So I feel like that's a throwback.
That's awesome.